Hi viewers, welcome to my channel. Today I am explaining about the grain size distribution of soil in the laboratory, how we will perform the experiment in the laboratory. Here the grain size analysis is widely used in the classification of soil. Here we are finding the classification of the soil. Whatever the data obtained from the grain size distribution curve is used in the design of filters for earth dams and to determine the suitability of soil and for road construction and airfields etc. So this is the information we obtained from the grain size analysis, and it can be used to protect the soil. Water movement although permeability tests are generally used. The grain size analysis is an attempt to determine the relative proportions of different grain sizes which make up a given soil mass. So we are finding the type of the soil, which kind of soil it is. Here the aim of the experiment is to find the classification of the soils, and next they select the sieves as per the IS specifications and perform the sieving. Next, to obtain the percentage of the soil retained on the each sieve, and finally draw the graph between the grain size of the soil and percentage final. Let's start the procedure. Here I am taking the soil sample is red soil. The weight of the soil is 1000 grams. 1 kg of soil sample I have taken. Take the exact 1 kg of soil. Now next arrange the sieves in the order. Yes, arrange the sieves in order. Pan 75 microns and 150 microns, 300 microns, 4.425 microns, 600 microns. Yes, next 1.1 mm, 2 mm, finally 4.75 mm. Yes, recheck the order once. Pan 75 microns, 150 microns, 300. Pan 75 microns, 150 microns. Arrange sieves in order only. Okay. 1 mm and finally 4.75 mm. Here the size of the sieve represents the grid. That grid represents the size. It means particle size 4.75 mm size, that grid. Next, the arrangement of sieve shaker. That is sieve shaker. In that middle we have to place the sieves, all sieves at that place. Now I am placing the sieves in the sieve shaker. Don't forget to place the lid. Okay, place the lid compulsory. Okay, add the, we have already taken the 1000 grams of this soil sample. Add that soil to these sieves. Close the lid and close the top lid also, that is the machine sieve shaker top plate completely. It should be tightly. Okay, if it is loose, that sieve shaker work in that working position, that sieves disturb from that sieve shaker. Here the on off button. Yes, we have already set the time 5 minutes. It's a maximum of 5 minutes. Sieve is enough to sieve the soil sample. Yes, time is up. So take out the all sieves from the sieve shaker. Yes, now take out all the sieves from the sieve shaker. In each sieve we have to see how much soil sample uh, retained from the respective sieve. It is a 4.75 mm sieve. The retain on that 4.75 sieve, mm sieve, how much soil is retained in that sieve. Some we will get the some losses in this. Why? Because if particularly same size of soil particle is present in that grids, some soil particles are struck in that. Just look at there, some soil particles are struck in that uh, sieves in that grids. Yes, similarly take similarly take the all the sieve size, all the sieve soil sample is written on the particular sieve. Okay, sir, note down that weights in the tabular column. I will show after this weights. Take the weight clearly and completely. That sieve is cleaned by our hand or any some brushes. Okay, so note on the weights. Yes, these are all the sizes of the soil particles. Look at here. Next, this is the tabular column we have some which we have first one serial number and second one is the ISC sizes, weighing balance. After that you and have next to place that mass retained on the each dish and take the and next weights, percentage of the mass retained to the total mass of the soil into 100. And next column is cumulative percentage retained and the final is cumulative finer. Okay, do the calculation here. Note down all the weights. After that, note down all the weights properly. After that, mass retained on the soil. How much retained on the soil? If you will write in the 0.097, just write in the gram. So 97 grams divided by 1000 only. Grams. We have taken the soil mass, total mass is 1000 grams. Kilograms. So I am writing here. Continue with I am writing here the grams. Okay, so 97 divided by 1000 grams into 100. Do the total procedure like that and complete the tabular column. After that you have to draw the semi-log graph. Taken that semi-log graph and draw the D10, D30 and D50 sizes. Okay, we have the sieve sizes, right? 4.75 and 420 microns. So take 1 mm 600 microns. So take the sieve sizes on the x-axis and the percentage finer is in the y-axis. Okay, percentage finer is last column of our tabular column. Take that percentage finer and draw the graph. Okay, and indicate the sizes to the corresponding percentage of finer. Okay, so from that you have to join all the points that we will get in the curve. Look at here, that curve shape is get. Okay, next, so we have to particularly take in that sizes percentage fineness or D10, D30 and D20, D30 and D60. Okay, take the D10 where the D10 10% of finer than the soil particles, that we have to note down that corresponding to the sieve size. Okay, take similarly to that of 30% and final get D60. So take those percentage sieve sizes values. Okay, D10 here I am getting 2.9 mm and D30 2 mm and finally D60 is 0.9 mm. So this is a graph. From this graph we have to find out the type of the soil, classification of the soil. Okay, so here take the CU and from the graph we will get the values D10, D30 and D60. D10 is 2.9 mm and D30 2 mm, D60 0.9 mm. These values are from the graph only. Okay, and then next have to find out the coefficient of uniformity. Coefficient of uniformity CU, representing as CU. So we have the formula for that. CU equals to D60 by D10. D60 by D10, this means 60% finer than the soil particle size. Okay, so 10% finer than the soil particle size here. Okay, so here the substitute the values. D60 value, what is a 0.9, and D10 value is 2.9 mm. So substitute those values. 0.9 divided by 2.9, that equals 0.31. Okay, next also find out the coefficient of curvature, CC, representing as CC. So here CC equals D30 whole square divided by D10 is multiplying with D60. Okay, this is the formula for finding coefficient of curvature. So here CC equals to, substitute those values in this formula. D30 is 2 and D10 is 2.9 and D60 is 0.9. After calculating these values, we will get the value as final value is 1.53. Okay, so these are the values. CU is 0.31 and CC is 1.53. So here we have some limitations for identify the classification of the soil. It means what type of soil, what kind of soil it is like, right? So here we have the limit for coefficient of curvature is 1 to 3. In between the value is 1 to 3. Okay, so here we got the value as 1.53. So this value is in between the 1 and 3, right? So this undergoes, this soil is, now the soil is confirmed as well graded soil. Well graded soil. Okay, actually we have three types of soils. Three types of soils are there. What are those? Gap graded soil, and poorly graded, and finally well graded. So poorly graded and that, what is that, gap graded, these are not in our places. This is some other conditions we will get that. But here in our states we find only that this type of soil only there. Okay, that is well graded soil. So here, so final conclusion of the this is grain size analysis, grain size distribution. From this experiment we can identify the classification of the soil. It means type of the soil. So here we are final conclude with the soil is well graded soil. Okay, this is the experiment. Do it. If you have any doubts, please comment it. Okay, thank you.